Hello everyone. Today we'll be looking at a topic in physics, which is the measuring of length, right? So first start by defining length. So length is simply the distance covered from by two points. Okay, for example, I'll write here, let's say point A to point B, right? So this distance from point A to point B, that is the length, right? Okay, now when we're measuring length, there are six, although there are more elements or instruments that are used to measure length, but today we'll only talk about six, which include the measuring tape, which is right here. I hope you can see it. Measuring tape. Now the measuring tape is one of the instruments that is used to measure a very large distance, right? For example, the length of a football field. Yeah, example is that length of the football field. Then the second instrument is a meter rule. Okay, now some of the things that a meter rule can measure is the length of a table. Okay, already I'm making this video I'm making this video right now on a table, so you can use a meter rule to measure the length of a table. Okay, then the third instrument used to measure length is the vernier calipers, right? So now the vernier caliper is an instrument used to measure slightly smaller objects. Okay, for example, what's this there is a diameter of a pipe, right? Usually used to measure the internal and the external cylindrical objects, for example the pipe that I've already talked about. Okay, then the fifth instrument to be talking about today is the micrometer screw gauge. Okay, which the micrometer screw gauge as well also measures very small amounts of distance, right? Then last but not the least is the engineer caliper. Okay, now the engineer's caliper, we rarely talk about it, or it's rarely examined in your exams because it is not a very important instrument, but we'll talk about how and why it's not very important. Okay, then today we'll focus on the vernier caliper and the micrometer screw gauge, as these instruments are examinable by ECZ, that is. Okay, so you must know these two instruments, what you can measure with them, and how to calculate those measurements, right? Okay, so the vernier caliper, as I have already said, it's used to measure the internal and external diameter of cylindrical objects. For example, pipes. Yeah, the definition is right here and the example is there. Now this is how a vernier caliper looks like. Okay, I hope you can see it. This is how a vernier caliper looks like. Then it has parts. Okay, some of the parts include the jaws, right? This is the inside jaw, which is right here. The inside jaw, it's labeled. Then this is the outside jaw, which is right here. Then this piece, right? This piece is an object that is being measured at the moment. Okay, so this is where you place the thing that you're about to measure. Then this is the vernier scale, and that is the main scale, right? So as you can see, there are two scales here. So when finding the measurement, this is where it becomes tricky, because you have to add the two scales and find them separately. Okay, so that is that. Then you should note, and this they like asking in some of the exams when you go to the first part of the physics paper, the accuracy, right? So the accuracy of a vernier caliper is 0.01 centimeters, right? 0.01 centimeters and 0.1 millimeters, meaning any digit which is not like this, or which is not in this range, will not be measured accurately by this instrument right here. Okay, that's that. Now, measuring of what's this micrometer screw gauge. So I have some examples, although first let me just read how you measure the micrometer screw gauge. First thing is that right here, I hope you can see. So you first get the reading on the main scale, which is this scale right here. Then the second thing you do is that you get the reading on the vernier scale. Then the last thing is that you have to add the two readings. Okay, you have to add the two readings. Now there is an example right here. There is an example 1, 2, 3. These are questions concerning the vernier caliper. Now we're going to do them together so that you know how to go about these questions. Okay, Okay, now let's start with how to measure. So if you remember correctly, we said that you have to get the reading on the main scale, the reading on the main scale, then you get the reading on the vernier scale, and then you add them together, which will give you the actual, length, right? So now when you look at what's this, the main scale, right, which is here, the main scale, yeah, how you get the reading on top here is that you get the digits, right, that are before the vernier scale. As you can see, the vernier scale starts from here going or heading in this direction, right? So you get the readings that are starting from here going in the opposite direction. That's how you get the reading on the vernier scale. Okay, so that being said, if you can see, this is 0 to 1, right? Oh, sorry, 1 is here, my bad, sorry. So from 0, right, from 0 to here, how much do you think we had to move to get to this point, right? So if this is 1, then meaning this is half of 1, so I would say 0 0.5 centimeters, right? 0 0.5 centimeters, because this is on the middle of 1. If you want to count, this is 0, this is 1, we like 0 0.1, 0 0.2, 0 0.3, 0 0.4, and 0 0.5. Okay, this is our 0 0.5. Then how do you get the reading on the on the vernier scale? So what you do is that you start from the 0 to where there is a line that is attached to another line in the vernier scale, right? So as you can see, this line right here, which is 1, is directly aligned with 5, right? So meaning we're getting the distance from here to here, right? Then how do we get that? So we just count 0, this is 1, 2, 3, 4, 5, right? Then when we get the figure 5, I'll write it separately here because we don't just put it there. You multiply it, right? You multiply it by the accuracy, okay? Which the accuracy is 0.01. Okay, this is the accuracy in centimeters, right? This is the accuracy, if you remember in the notes. Okay, now when you multiply this with that, it will give you 0.05, right? Then the 0.05, you then place it there, so you say 0.05. Then last but not the least, you add the two lengths, which will give you 0.55. Okay, that will be the answer in centimeters. Okay, right? From there we do the second question. So we've done this question, we go to this question right here. Okay, now this question is almost similar to this one, if you can see, but the difference is here, right? There is 0 to 0 1, so meaning the reading is different. Okay, now so how we get the reading is that first we get the main reading, which is on top there. Then how do we get it? We first look at these digits, right? So if this is 2, meaning this is 1, right? This is 1. Then if this is 1, how long do you think these digits are, right? So basically you just deal with math, right? So if this is 1, you say okay, basically this is 2, right? Because when you start from 0, this will be like 2, 4, 6, 8, 10, which is 1. Okay, so like 0 0.2, 0 0.4, 0 0.3, 0 0.8, and this is 1. Okay, so meaning you're getting the reading from there to where this is starting from. So you just basically write 1. Sorry for wasting your time. That was really well. You just get 1, but I was just showing you how you find this. Okay, but you get 1. Okay, so you just say 1, right? Okay, then from there we get the reading on the the vernier scale. Okay, you get the reading on the vernier scale, of which you look for a line that is aligned with any reading on the main scale, which is 5 again, as you can see. Okay, so from here to here, what's the figure that you're getting from the reading there is 5. Okay, then again the 5 you multiply it by the accuracy, which is 0.01, which will give you 0.05, right? Then you place your 0.05 there. Then you add the 2, which will give you 1.05, and that will be your answer in centimeters. Okay, hope you can see. Then the last question, this is the last question. How do you find the accuracy? Okay, so you look at the digits again. but this one is different because the vernier scale is starting from 0 right here. Yeah, so you just basically get a 0 because immediately where there is 0, there is the vernier scale. So you just get 0, which is the reading on your main scale. Then you get where they're aligning. Then from there you just count from like 1 2 3 4 5 6 7. Then the 7, when you get the 7, you multiply by the accuracy again, which is 0.1, which will give you 0.07. Then when you add 0.07, the answer, oh sorry, yeah, this will be the answer. Yeah, then from there we go to the micrometer screw gauge. Okay, now we talk about the micrometer screw gauge. So the micrometer screw gauge is basically an instrument that is used to measure very small dimensions of length. For example, the thickness of a metal wire, the thickness of hair, and the thickness of paper, right? This paper right here, the paper I'm using, like this thickness right here. Yeah, that is the instrument that we use to measure that type of length, right? Now, here are some of the parts. Sorry, I forgot to label them. This is the anvil, right? This is the anvil. Sorry, I forgot to label these parts. And this is the spindle, right? Then these two parts is where an object, this is an object by the way, sorry, is an object where the object is placed. Okay, the spindle and the anvil. Now we have this part, which is the sleeve. Okay, and the sleeve basically contains contains the main scale. Yeah, this is the main scale. Then we have the thimble. Okay, we have the thimble, which contains the vernier scale. Okay, contains the vernier scale and the wrench. Okay, now these are the parts of a micrometer screw gauge. Now, how to read a micrometer screw gauge is that if anything, it's the same compared to the vernier calipers. You just get the reading on the main scale, sorry, plus the reading on the vernier scale. Then when you add them together, you will get the reading in overall. Now, you should know the precautions that are taken before using a micrometer screw gauge, as this question is usually asked in the exam. Okay, so the precautions are just 4. You can memorize 2, you can memorize all of them depending on how sharp you are, but you should know them. So the first one is that you should wipe the dust from the anvil and the spindle. Okay, this is because those dust particles can be measured together. This is why this is usually advised. Then again, you should wipe the object to be measured. You should wipe the object of any material, any waste that could be attached to it. Then the third one is that the rate should be used to tighten the material, which is here, right? Then when you hear a clamp, right? When you hear a clamp, you should stop using it, as if you continue, you might destroy the object or destroy the micrometer screw gauge. Okay, then the last one is that you should correct the zero error. You should zero the micrometer screw gauge. This just basically means if the micrometer screw gauge had a certain reading, let's say 10, you should move that reading to 0 so that you can calculate properly. Okay, now how you get the reading now on the micrometer screw gauge. So I have three examples, which is this one, and that one. Now please follow me carefully, because this is very important. So the first one, which is A, how you get the reading. So you first look at the main scale, which is this one. Okay, the main scale, which is this one. So you say from here, this is like 1, or this is 2, 3, 4, 5, 6, right? So you say 6. Okay, then there is this reading down here. Now this reading should not be neglected regardless, okay, because this will affect your answer. Now if you see that there is a line that is in front of where this scale is ending, meaning this line will be a 0.5. okay, this is a 0.5, which basically means it's half of this, right? So you must include this. Okay, so you say where there's 3, you say add 0.5, which is half, right? Then how you get now the reading on the the micrometer scale, this scale right here, is that you also get the the digit that is aligned with the main scale. As you can see, from 80 we have 85, so meaning this is 81, 82, 83, 84, and 85. So this line right here represents 81, right? You write it separately as well, then you multiply. You should never forget to multiply the this digit by the accuracy, because if you do not, the answer will be wrong. So you multiply by the accuracy, which is 0.01 millimeters. It's in millimeters because we are dealing with a micrometer screw gauge. So when you multiply that, the answer will be 0.81. Then you just write 0.81. Then you just add all the figures here, okay? So 1.00, that's 1. 5 plus 8, that should be 13. Carry 1, then 6 plus 0 plus 1, that's 7. So this will be your answer. Okay, we go to the second one. Okay, the second question, which is right here, I hope you can see it. So this question, yeah, if you can see, as I've said earlier, you have to get the reading on the main scale, right? So how do you get the reading? You just count. You say 1. Oh, sorry, this is, yeah, just say, okay, you start from where the figure is. So we've been given 6, right? 6, so this is 5, 4, 3, 2, 1, 0, right? So from 6 we have 7, right? So we get our 7, we write it. Oh, let me write it somewhere here so that this is B, by the way. 7, right? 7, we've gotten 7. Then as you can see, there is this line which is exceeding, or which is in front of the scale on top. And as I said earlier on this question, is that when there's a line exceeding or in front of this scale, meaning this is 0.5, okay? So if it's 0.5, you say 0.5, right? Then how you get, so what is the reading on the vernier scale, is that you look at the line that is aligned with the main scale, right? Which is aligned. So you start counting from here. You say 29, this is 30, 31, 32, 33, 34, and 35. So this line is 31. Yeah, so you just say 31 and multiplied by the accuracy. And I'm repeating again, please do not forget to multiply with the accuracy, okay? Please do not forget to multiply with the accuracy, as I've done here. So 31, which we've both agreed on here, 31 times the accuracy in millimeters, the answer will be 0.31, okay? And from there, you just add the 3, right? You add the 3. So this is 1 plus 0, 0, that's 1. Then this is 5 plus 3, that's 8. Then this is 7 plus 0, 0, and that's 7. So this will be your answer in millimeters. And last but not the least question, I hope you can see it, is right here. Okay, is right here. So we start by getting the reading on the main scale. I hope you haven't forgotten. Reading on the main scale, right? So the reading on the main scale, so we start from here, 5, 6, 7, 8, right? So meaning on top we have an 8 figure. Yeah, I'll just write it here. Sorry, I don't have enough space. I'll write it here. So we say 8, right? Then we look at this scale down, right? The scale on the bottom. So when we look at this, the last line, right? It's not in front of this one. It's not exceeding, right? So meaning this one is not 0, or it's not 0.5, right? Because it's not exceeding. So you ignore this scale. Then how you get now the reading on the main scale is you look at the line that is aligned with, the main scale, which in this case is 5. If you can see, sorry, this is a 5. This is a 5. So we just say 5. I'll write it here. 5. Just write it somewhere. Then multiply by the accuracy. And I'm repeating again, this is very important. Never forget to multiply by the accuracy. So when you multiply by the accuracy, this is 0.05, right? So you say 0.05. So when you add the 2, your answer will be 8.05 millimeters. Okay, now this is the last question, and this is the end of our tutorial. I hope you've gained some knowledge from whatever I've explained. If it wasn't clear, my apologies. And please don't forget to like and subscribe, and we love you guys. Okay, thank you very much.